Hello. Okay, so welcome to a short little lecture about how to use Excel. I thought this made sense because this was quite central, or will be quite central for all statistical operations and functions that you will be using down the road. I think it made sense that you have a solid grasp on how to use Excel. And you will see whatever profession you essentially will be choosing, whatever direction you will be going, whether you do research or whether you go into accounting or economics, simulations for whatever purpose. You'll do it some form of tabulating software, with Excel just being the market leader. And it's always a kind of the way of thinking when trying to master functions in Excel, due to some extent also apply to different statistical software. So you will essentially all have everything formatted in a way that you have columns, which are here labeled A, B, C, D, all the way up to, that's all trick number one. When you press Command and you press the cursor, it will actually get you at the very of the spreadsheet. So literally, this is here the last spreadsheet in the entire Excel table. So this XFD starts to W's or the letter goes to A, it goes to AA, and A to AA to C. And that's the entry really here is XFD. But this is a lot of variables, right? A lot of columns. If you back to A, you can do the same by pressing the cursor down. Basically, it gets you here to it's 1,048,576. So these are all the entries that we can tabulate. Of note, and those of you that have me in class, you know already that I work a lot with big data, and sometimes you have more than 1 million and 45,000. How much was it? Yeah, that million of entries. And if you have more, basically Excel will cut it. And this is actually something you got to be very careful whenever you get a data set from any other software like SAS or SPSS, whichever. SPSS doesn't do well with big data, but SAS, for example, is often data sets with much more entries. And you import them into Excel, you will essentially only see a part of your spreadsheet, and you need to be aware of that because you may mistakenly think this is the entire data, but it's actually not. Just keep it in mind. Okay, so what do we have? So we have here cells and rows, columns and rows. We have columns labeled with A, rows labeled with numbers. As a resultant of that, you get the location of each cell here represented on the left upper corner. So you get A1, B2 for this one. This is C3, this is D4. So you basically can go through the entire list. Why is that important? Because sometimes you want to locate a specific cell, and you will need that for the functions. So essentially, when you think of functions, they all address one specific cell here. So you have here a number, this is 1, and you have 1, and you want to have, let's say, the sum, or you want to add these up. You can say either you just click and say, and this basically adds you this and this cell. So this is equals, equal sign indicates that there's an arithmetic operation coming. C10 is not a cell, separating it as a mathematical operator essentially does exactly that mathematical operation on this cell and another cell. In this case, it adds them both up. So 1 and 2 is 3. And this can be all easily addressed with just using the cell address. Of note, and I just quickly want to point that out to you. So those of you that are analytically inclined and kind of go into coding, there is a way to get this in a more general format, which is easier for programming purposes. And you go on preferences and you can generate. So I'm on a Mac. which is maybe a different experience in Windows, but basically it should be the same context, kind of the same presentation. So if you go on preferences in general, you can change to what is called here an R1C1 reference style. And once you do that, you go back out. And now you basically have a different presentation. You have R1C1. So R stands for row, C stands for column. So it's row 1, column 1, row 5, column 5. So this is important when you do coding in iterative loop. In iterative loops, for example, you code something and you add 1, you have a counter with your loop, and you add 1, and you kind of want to assign that to a certain part in your formula and in your spreadsheet. You can use this reference style to envision your data better and kind of address things more adequately and in a more in an easier way. Those of you that are not analytically inclined, just forget what I just showed you. But there is an R1C1 style how you can express your data. So, but commonly accepted, and this is the default setting, you will have all the columns with letters and all the rows with numbers. So what does this mean? Now, actually, R1C1, you will notice the one thing, and you will hopefully remember this from class. Whenever you address a certain cell in R, you're doing the same way. You basically, with the brackets, you are phrasing a certain location within your data frame. The first part of the inside of the content of this bracket before the comma will indicate the row. So if you have row 5, column 5, just we had, like we just had, you will indicate it by data frame, let's say call it DF, bracket, row, comma, column, which is consistent with the R1C1 style here. So you have row first, comma, column. Why is that important? Because this is just a general way of how how these cells are addressed. For example, you have here also in Excel, you have something that is called Visual Basic. You need to activate the additional tab here, which is called your developer. And you can, in this tab, you can create what is called here macro. You can develop macros, and these macros essentially will allow you to program in Excel. That sounds now all a little complicated and absolutely not relevant to this class. I just want to show you what the functions are and what you can actually do in Excel. Off note, I actually programmed quite a bit in Visual Basic, and it's quite a useful software at times. What you can, for example, do, as a note, you can record your actions in Excel, and you can alter them in a way that you programmatically do and repeat whatever you have been doing. So let's say you have a task like clicking here, adding this, and then dragging it here, and you need to do that 100 times. You do it once, you create a macro for that, and then you basically tell the macro, just repeat the same thing 100 times and do it in different locations. Okay, but this is absolutely far off the scope of what I mean to show you. I want you to understand that this is an extremely powerful tool, and having a basic knowledge in it is can be very, very helpful to you. Okay, so we have here 2 cells. These 2 cells are essentially having some shape and form and have some value to it. So let's bring this a little bit more in an actual data frame context. So let's say we have 10 individuals. So you see how annoying this is. So I just entered 10 different numbers. I counted up from 1 to 10. Another way of how you can do this is you start the first 2 entries of such a row of entries, and you select these 2 entries, and then you go here. So you see here, I'm zooming in a bit. I assume this is going to be a little hard to see. No, this is better now. So you have a row of such an increasing sequence. So basically you select the first two entries. You go to the right lower corner and you see here, you have here a white cross and you hover over this. So first of all, you have here, when you click over this, the rim of the selection, you can drag and move this entire thing. So this is equal to pressing Command and X or Control and X, which also allows you to drag and drop it. So you can do this also by having this white cleft Mickey Mouse cleft that basically allows you to grab the selection. So you hover over this whole thing, you have here white cross, you hover over it, white cleft, you're back on white cross, and here on the right lower corner, it suddenly turns into a black cross. So what does this mean? If I'm dragging this to the right, it just changes it. So if you once you copied something, you essentially always get like this small little help sign. This help sign allows you to select either copy cells, fill series, fill formatting only, or fill without formatting. So fill formatting only essentially just fills the formatting. That means like if I have here now, let's say I make it bold. What did I do? Let's say I make this thing bold. I select the first cell and I make this bold and I make this underlined. Okay. So now I go here and I go on this white little black cross, I go here, drag this over. This has been copied already. Let's say I go here, copy cells, it's clear, right? Copies the cell. If it fills the series, it fills the series. So it basically goes 1, 2, 1, 2, 1, 2. And copy is essentially the same thing in this context. I will show you when it's not the same thing. Fill without formatting means like it will not bring that formatting forward. So now it's not formatted, only this is bold and underlined. This is not bold and underlined. So let's go back. Because I will show you what fill this formatting is, because fill formatting only makes the numerical values disappear, and whatever I write in here now is bold and underlined. So it's only propagating the formatting. It's not necessarily that important, but I just want you to understand the basics of things, what this little cross actually means and what the powerful tool that actually is. Okay, so let's say we're dragging this down now, this whole thing. Good. Again, here's the little first 8 kind of. So if box, if we go and copy cells, it copies the cells. It copies 1, 2, 1, 2, 1, 2, 1, 2. I go back here, I go and fill series. Now it fills the series from 1 to 2 up to 10. I go back to the first 8, I go and fill formatting only brings the formatting forward. Back to the band-aid, fill without formatting, all the way down. Now we go to flash fill. That was nice. Okay, good. I don't know flash fill, that was before my time. Okay, I can play around with this later. Okay, now that's important. Good, but this is the basic function. It's much faster than writing these numbers down 10 times. And you can do this ad infinitum, so all the way down, you can fill the series in the same fashion. Good, okay. Let's see, we have now 10 subjects. Okay, so I'm a researcher. For me, everybody, as soon as RP approval is obtained and part of my research study, gives a subject. Not a student anymore, not a patient anymore, not a random bypasser anymore. It becomes a subject as soon as part of the research study, the research subject. Good. Research subject 1 on first attempt is able in a lot of in any kind of game to get 10 candies, 15 candies. The second one, third one gets 11, fourth one gets 4 candies. That one was a little faster, gets 7. We have a slow one, gets 3. Then we have another one with 11, one with 12, one with 14. Let's make this one a 9. Good. So we have now the first attempt, and now because we want to know what to do, second attempt, we get now let's say this one gets less, this one gets less, this one gets more, this one gets more, this one gets more, this one gets more, this one gets less, 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 not more. Good. So now we want to count how many of these are higher. How many of these have more than on the first attempt and on second attempt? So first of all, let's build the sum. So how many of these candies have been given out? So sum of that, SUM, equal sign indicates a function is following. Sum is a simple function that basically allows you to grab the sum of whatever is stated in that column or in this array. The array is indicated by the first cell, the starting cell, the column sign, and and the end cell. So it's number 1, number 2, number 3, number up until number 10. So this sum is now 95. Now we do this for the second one. Now we can do sum. We can do sum, first entry, second entry, third entry, fourth entry, fifth entry, second entry, ninth entry, 9 and 10. Good. Same thing. So it is essentially what column does. It removes redundancies. So we have C2 to C11 is equal to C2 colon C11. So it comes to the same thing. So now we want to add those up, and we want the sum of sums is now this one plus this one. Or alternatively, it's the sum of B2 to C11. So it comes to the same thing. So you really need to think in arrays. You take the first entry and you take the last entry. And if this spans 2 columns, it spans 2 columns, doesn't matter. Excel doesn't mind. So now we want to understand how many grabbed more. So more candy on second attempt. So now there are several ways how to do that, right? One interesting, easy way is, and those of you analytically inclined will know already, the so-called if function. If you're telling Excel, and this is the simplest way of using an if function, if. So now if you type a function, so now the sum function is pretty straightforward, right? But if you have a little bit more of a complex function, you get an if, then it opens up parentheses here. And it gives you the entries it's demanding now. So it wants a logical test. It wants a value if true, and it wants a value if false. What does that mean? If, what is the logical test? We want to know whether the participant, the subject, had more candies on the second attempt of grabbing a quickly out of the box or whatever. It's like just make up any story now, not relevant. So if the first attempt, or if the second attempt was greater, and this is the greater sign, you use the greater and equal sign for these kind of calculations or logical testing. If C2 is greater than B2, then give me a 1, otherwise give me a 0. What does this mean? So now I'm getting a 0 because second attempt was smaller than first attempt. If I'm now clicking on, and this is the second thing, okay, so we're hovering over same story. White cross, white cloth, white cross. We're going to the black cross. We can now pull this just down in the same fashion as we have done it. Or alternatively, if we have a list that has an end, and we are using the same function on the entire list, and we're just double clicking the red cross, it will propagate this all the way down. And again, giving us the Band-Aid box. Yeah. spell formatting only gets us back to where we were. So now we're doing this. Okay, so now I want to know how many subjects have now completed, and this is actually this is coding. In statistical programming, we refer to this as dummy coding. Dummy coding, because this is the so-called dummy variable. And this dummy variable is actually very powerful because it's an outcome. It's an outcome of two measurements. But this outcome essentially is now reflecting a research question. Because a possible research question could be, okay, so I have this bowl, or have this I don't know, like some kind of parkour with obstacles, and they have to grab candy, or I don't know, just any kind of random thing you could make up to visualize it. So they did something on the first attempt, but they had less, actually, in some, they had less success on the second attempt. So now, was this true for individuals too, or was it just numerically less? That's not the question, right? Was it just that some individuals were not able to grasp as much on the second time, so because they were exhausted, or I don't know, this time those that had a certain number of candies obtained on the first run had now, I don't know, the hands tied to the back, or I don't know, something like that. Or alternatively, could it be that just there were less candies around and they couldn't grab more? Or whatever you could think of. But the research question here, for example, could be, okay, so I assume that on the first attempt and second attempt, there will be no difference between the candy grabbing. So same amount of candy. So now I want to test this on an individual level. I want to understand and how many participants had now less or more candies on the second attempt. One way to do is basically compute the outcome for each of the individual, and that outcome is consistent with my research question. So if my research question is, do participants get more candy on the second attempt? Null hypothesis, and we all know what that is. There's no difference. There's no candy difference. Research hypothesis, there is a difference. Good. So now, the easiest way to do this is to recode this in zeros and one, make this a so-called binary outcome. At this point, this outcome is not numerically anymore. At this point, the outcome is recoded in a binary categorical variable. So now I can just use the numerical value of 1 to basically come to a sum, and the number of individuals grabbed more candies in second attempt. So what do I conclude out of this? That it's not something that has to do with individuals, it has to do something with the candies. The individuals were still the same number of individuals, half of the individuals essentially caught more on the second attempt. So there's no difference in the number of individuals that grabbed more candies. So now who had, let's try to phrase something else. Let's do third attempt. Third attempt. Let's say now it was 12. Now it's going to be 11, 10. Now we do here 9. Now we do here 6. We do 5. We do 7. We do 13. Here we do 4. And here we do. Okay. So now we have a third one. And now we can, again, so we have here the same sum built for all of us, right? So we have now, we can just propagate it over. We just carried over this equation Again, it's the sum of D2 to D11. We selected both, so hypothetically it would have needed to propagate both over. It didn't do that because it recognized that this is essentially the more, that's actually a terrible formula. So it tells me already, okay, so there's an inconsistent formula between the left one and the right one. And it asks already, okay, so do you want to edit it? Do you want to ignore the error? Do you want to check with different, do you want to help on this error? Or do you want to copy the formula on the left? So now we know this formula is actually unnecessarily redundant, so we can just copy the formula from the left. So now we have the same formula on the left. And it comes to the same end, so it will also recognize that. It actually knows what you're doing, and it understands you pretty clearly. So now we want to do the same attempt. So now we want to know more candy on third attempt versus second. So now we go for with the if. So if this is more than this, not this, then 1, otherwise 0. Okay. So here, first subject has already more on the third attempt. So he learned his lesson. He knows now how to grab the most candies. Second one did have less, got a little lazy. Now we can propagate this all the way down. So we populate this all down again with our black error. So now we see suddenly this is not 5 anymore. This is not 4. So 1 fell out. Who fell out? Now I want to know who that was. But so you got to think of this as like, now you look at this and this is easily understandable, like visually. You just look at that and like, you know already what's going on, right? So you know exactly which one that was, crab glass now, and you know this is this guy. So, okay. Actually, it's not this guy. Or maybe this. Okay. So now we want to know who had more on first, on second, but less on third, but less on third. So now we're getting specific. So who had more on the second attempt? So who had, okay, so if, and I'm showing explicitly such complicated formula because it can get complicated and even more complicated. You can spin this as long as you want them, but that you really got a very interesting kind of way of looking at it. So who had more on second but less on third? So this is like, and if this is 1, and for and we're using the ampersand, and less on third, and this is 0, then a 1, otherwise a 0. How many are these? Oh, none. Okay. So now we can use the second one. So who had more on second? Who had more on second, but on third more than on first? And this is how you really you can do quickly oversee large data amounts. So you have more on second. This if E2 equals 1 and another parentheses. So you can, with a parenthesis, you can even extend this more. And this was more than this. Then 1 otherwise. Yes. Okay. Again, now look at that. Okay. Enough of this. Before credit. Before. And what do we see here? My formula was not correct. And why is it not correct? Because we want to have, no, well, it was correct. Okay, no, it's not correct. Okay, so we have here who had more on second, but less on third. See, that's where you have to think more complicated actually. So it's who had more on second, but less on third. So now we have this coupled with this. So this is correct, right? But, sorry, I have to send it to mouse again. But now here, we're actually not getting away with this, because here we have, if E2 is 1, E2 is this, so more candy on the second attempt, but ended up having more on the third than on the first. Who had more on second? That's actually the question. The question not or more on third, more on third than on more on third. That's actually what I meant to say. Okay, more on third than on first. But sometimes I have to prepare for this. Okay, so now we have either more on second or more on third. And this can be done with the so-called OR. So this is reached by shift, and above the return sign, there's a little slash that is going backwards, which is the backslash, and you get this sign. Mm-hmm. Mm-hmm. Interesting. Learning something about. Oh. Okay, I gotta make this. Okay, we're gonna make this more complicated. Okay. Logical test, value if true, we need to do if. We need to do an if and an if. So if this is greater than this, then 1, otherwise 0. Okay, so what do we have now? Okay, this is got more complicated than I actually wanted it to be. So we have now, we have 3 left. Okay, got more complicated. Okay, what do we have? We have here, if E2 equals 1, which is true here, for example, with this guy, this is true. So if E4 equals 1, yes, it is. Then go on, and this is if true, you're taking a second if formula. You go if D4, which is this, third attempt, is greater than B4, which is 11, then 1, otherwise 0. If not, then make the 0 altogether. So this is value of false. So this is how you can do that. I tried to do it with an OR. So in R, for example, you do it with this logical OR. So you basically say it's either that, either condition 1 or condition 2. But don't worry about this for now. It's just I wanted to show you this, not necessarily important. Okay, so we have here 3 left. 3 that basically had more on second or more on third compared to the first. So this is all a little complicated. I want to go back now to more simpler things. So now we have talked about this. We have talked about sums. We can now compare the sums. We can build averages. Averages are done by average, as we know. The average of this is 9.5. Then we have averages of this, and this is now interesting. So you can do the same thing with a formula everywhere you are. You basically have a formula for this column now. You're basically going one column to the right, and you can do this with the second column easily. So you can go back and forth. You can build formula. You can also bring this formula down. So now it shifts it down, right? So now it's basically it's shifted one cell down, because now you copied that formula one cell down. What do you want to do to prevent that? You're locking it in, and you're locking it in by putting a $ in front of. If you want to preserve the column, you put a $ before the column. If you want to preserve only the number or the number and the column, you essentially go and put the $ before that. So now what we want to do, we only want to preserve the number. So we only preserve the number, and we're locking the number in. So it means the column can change when we drag it to the right. That column will change. If we drag it to the left, that column will change, but the numbers will be the same regardless of whether we drag it down or not. What does that mean? So now here we have 8.33, which is shifted one cell down. We're doing the same thing here, and we're shifting it down. It will now still be 8.4 because it's still locked in the numbers. However, if we're dragging it now to the left, it's still 9.5 because the numbers locked in the rows, but the column have changed, and the column is now B because we shifted the one to the left. Makes sense, right? It's quite a logical principle. What else can you do? What's nice? You can, for example, also select a row. You can do something which is also quite helpful when you have long lists of that kind. You can do conditional formatting, always nice. If you have, you can highlight cells rules. You have various aspects. I just give you the simple ones. If you have highlight cells rules and you have cells that are equal to, we can do also greater or smaller to. But when you have format only contains a cell value equal to, here you can change it to between, not equal to, greater than, less, greater than, equal to. If you have a 1, then format it with, well, green fill with dark green. Sounds good. Okay, so if this is 1, then format it in a certain way, and it formats us all the ones. Good. So now we have here conditional formatting. Now highlight all that are greater than, actually greater equal than, greater equal, greater than or equal to 10. Now we do the light red. Okay. So by this, you're getting here overviews. You get an idea what your data looks like. You can quickly visually inspect your data. Then now you can also do the following. Okay, let's do something. Let's add here names. Let's say this is Tim, this is Joe, this is John, this is Maria, this is Eva, this is Thomas, this is Joseph, Sarah, Helen Blank, Evelyn, and Martha. Okay, so now we have here names. So if we have these names and we want to do something with these names, we can do something very interesting. So we can now, for example, concatenate names. We can say, look, we have here 2 cells. One contains a character, another one also contains a character. We can now create a list using each component of these cells in a tabular way. So this would be concatenate, very powerful function. You have text one, concatenate. We have a text. We're taking Tim, comma, indicates a second text fragment. Tim was quotation marks. You basically indicate, so now you're writing something and you want this to be part of the concatenate, but not included. So take nothing from the cell, but take what I'm writing now. Tim, who was subject, actually we can, who was, it also takes the spaces. So if you want a space, you need to make a space in between. Who was subject number, comma, now we do comma, we're indicating there's a new thing coming. We need to close it with a quotation mark. Now we do who was subject number one, comma, got quotation mark, comma, 10, got 10, quotation mark, on the quotation mark, comma, first attempt, we can take from there, we're looking that in, comma, quotation mark, end, comma, no, space, and now we can drop the second number, comma, quotation mark, on the comma, quotation mark, comma, second attempt, dropping that in. You see already where this is going, right? This is just playing around. This is not really something you will be needing. But it's basically when you are populating tables for a scientific paper, this is very powerful knowledge to have, and this can save you a lot of grief and time, essentially, bluntly spoken, because it can be very tedious redoing all things. Okay, Tim, who was subject number one, got 10 on the first attempt and 9 on the second attempt. And this basically comes up here from our data. So now we want to propagate this all the way down. We basically get this for all our 10 subjects. Also, if you go further, it's populating rubbish. So yeah, admittedly, this what we're doing right now is also kind of rubbishy, but it's basically it's an idea of how you basically get a handle on data in your Excel. Okay, so we have now concatenated stuff. Well, this is, for example, quite important is whenever you present scientific data, you will always present it in the following format. So you present it at mean plus minus standard deviation. So if you have a standard deviation here of calculated for this here, let's shift this all down, and you can shift everything. It's like all the formula will be preserved. So this is our average. No, this is not an average. This is the average. So this is not the average. So this is average. This is average. Now we do standard deviation. Standard deviation is STDEF. STDEF for these 10 entries. And STDEF for these other entries. Okay, so mean standard deviation is concatenate. This is how you will put concatenate. The way you will be presenting this is basically average T17, comma, gets your second text block, quotation mark, plus, slash, minus, quotation mark closed, And now you have a little bit of a problem. Okay, we can close it like this, and we just close the parentheses, and then you have this here, 9.5 plus minus 3.86, blah, blah, blah. So nobody was, yeah, nobody really needs that many decimals, right? It's nice to have decimals, and it's usually nice when to keep them as long as possible. But when you express them in a table, nobody wants to see 10 decimals. I would go depending on the numerical value you're dealing with. When you have a really small value, obviously it doesn't merit to have more decimals. But if you really have a considerably normal, quote unquote, normally sized numbers, like here's candies, like nobody eats 0.02 candies. So essentially you take something that is like 1 decimal max. But you go with round. Round is a function that basically allows you to round the whole thing. You just change G19 to round, and here round the functions round, number, num digits. So you indicate before the comma, you indicate the number. With num digits, you indicate how many decimals you want. If you make a 1 there, it's gonna make you 1. It gives you 1 decimal. So now it's down to 1 decimal. And now you're dragging, dropping that over, and you get it for the second column. You copy the header, and here we go. So now when you do a median, and median is usually presented as 25th to 75th, 25th semicolon, 75th percentile. That's a quite accepted way to present medians and non-parametric data. Okay, so how are we going to do this? Again, concatenate. Concatenate is median. Okay. Median. Okay, don't do that yet. It doesn't matter. Median, we don't need to calculate the median, we can do it in the formula. So it's the median from here to there, to comma. And now it's getting a little trickier. So now we need to do quotation mark, bracket, open, bracket, close, with quotation mark, comma. So now we need the 25th percentile. Good, same problem. So we're doing quantile. Percentile. Percentile array 25. Good, we closed it. Now we're doing comma, quotation mark, open. Actually, semicolon, space, quotation mark closed. And we're doing the same thing, percentile, percentile, C2 to C11, 75. And we're not closing this yet, we're doing another comma, quotation mark, bracket closed. So this did not work, and it likely didn't work because I'm not using Excel that often, so percentile didn't work as hoped for. So 25 not work, and I know probably what the issue is. It's 0.25. Here we go. Okay, 0.25, not 25. So we are revisiting. So whenever this sign comes up, it means it's something numerically, but I can't deal with it. So it's basically actually complaining that you fed it rubbish. So okay, so you're going here, you're doing 0.25, you're going to do 75, you do 0.75, and here we go. That's our result. So we are having 10.5 median, 7.5, 25th percentile, and 11.75. So now we can just copy the whole thing over. We're doing Command C, we're doing Command V, same thing, and we have finished. Now we can highlight the whole thing, put a border around it. Always looks nice. We're doing a thick box, thick bottom, thick outside borders. That looks nice. Give it a little bit of color. That looks nice. Good. All right, enough of this. So now we want to know more. Now we want to know, okay, so what determined whether an individual had whether an individual had, we want to know whether the first attempt, the candy grabbing outcome from the first attempt predicted the second outcome. So essentially that can be done with the scatter plot. We're selecting the first two columns. We're getting now our scatter plot, first and second attempt. Okay. So the scatter plot is easily always depicted here. So basically, we have now with the scatter plot, we can go on format chart area. We have the fill. Now we have the here the axis. We can label the axis. That's always nice. Okay. Axis options. How to label it? We are now labeling the axis. Take marks labels. So we got label position. We don't have a label text options. We don't have a text. Again, same problem. I'm not using Excel that often. There's a reason for that. Format chart area. No, we're not doing that. Just did that. We are now doing data points. Let's see what's on. I'm going to right click, select data. So sheet D1 is our second label. Yes. So we have here two series, C1 to D1. So we basically we're having now the sheet name is actually candies. Candies. Okay, name is candies. Candies from first to second. Okay, complete that. You can also write directly into it. Axis title, other format axis. Change chart that font, add format axis here. Format axis here we have this, axis closest to the unit, values, tick marks, no tick marks, labels, label position, number, general format, link to source, yes. Interesting. They made this more complicated now. Okay. You never stop learning. Good. Okay, we do select data. Data. We do select data and we're changing now C2 to D11 legend entries series candies from yes. The axis labels, horizontal category axis labels. Coming from C1 to D11. I didn't carry it over. That's fine. Okay, let's get to C1 to D11. Did not work. Oh, good. Okay. So back to the axis titles, we basically, so now we have up here, we just click through the respective tabs here, and we find up here, we find chart design. Here we have add chart element. So that also brings us essentially, I want to add a trend line, so we can add a linear trend line. So it goes through the whole data scatter, fitting it using a least square method. And now we're going to access titles, primary horizontal. And here we're getting now access title, and we can customize this. We can add here second attempt, because that's our, yes. And whenever you select two rows, two columns, and you run from that, and this is true for Excel as well as R and most other statistical softwares, the first mentioned column variable is always going to be on the x-axis. So this is actually the first attempt. And then we have add chart element. Okay, so this is first attempt. Now we click on this. We're going back to our chart design. We're adding chart element, axis titles, primary vertical. And this is second attempt. Good. That was terrible. Don't know what I want there. Attempt. Okay. Good. So this is now that little chart. Okay. Good. So these are the main things now that we need to know from building a chart. So now, what else do we have? Okay, we have now, so since this is a data row, so we have here the different sheets. We can always create new sheets. So now we have the candy example. And now we have candy examples. We're making a sub-selection with candy examples for females only. So now we're going candy example, we're going back there. Okay, so now we need an additional variable, and we're saying now female, yes, no. So female, yes, no. And again, note, usually traditionally we would say, okay, so okay, gender. Let's start. So this Tim strikes me as male. Joe strikes me as male. Male. John is male. Maria is female. Eva is female. Thomas is male. Joseph is male. Sarah is female. Evelyn is female. Martha is female. Good. You saw that there's also already pre-autofilling, so that's also quite helpful. So now we want to dummy code gender again. So now we do female 0 and 1, and this is an approach. So those of you that are being tortured with coding SAS and SPSS, you will likely encounter a different coding where it's 1 and 2. Other nonsense in my head, but I have never heard an explanation why this is being done. But again, there may be reasons I just don't understand. I think it's better to code them in 0 and 1. So if C2 equals quotation marks female, quotation mark closed, then make it 1, otherwise it's a 0. Males are 0s, females are 1s. Good. So we know now we have, so how many males and how many females do we have? We have some D2 to D11. Good. 5 females, 5 males. Good. Now we want to only copy the results of the females. How can we do that? Quite easy. We're selecting our data set. We're selecting all of it that is basically ending. So only the data set, not the summary statistics down there. So this is summary statistics, don't touch it. So now go on data, go on filter. Obviously, you can also sort the data. And we have, yeah. So there is, if you sort them by males and females, you go from value largest to smallest, you will essentially sort your data by 0 and 1s. So now you have the females already all there. So you have them separated. Now you can copy them and bring them to the other table. Notably, this does not affect your calculations. So if you order within the data frame, it will not change your calculations. So reverting this gets us back to the previous order. So now the subject is again. So sorting is one way to do that. Another way to do that is filtering. If you click on filter, you basically get these little pull down menus here. You see those? And if you go now on females, you only take those, and here you have here ascending, descending. Here you can sort it within the filter. You don't do that. You can do color and color around, whatever you want to do. You can also deselect all of them, and you can select only the ones. Okay. And now we have a selection of only the ones. So these are only the females. If we press Command C, or we select the whole thing and we copy it, and we're going in the other spreadsheet, we're only getting the females copied over. If we are going back on the initial worksheet and we're pressing, we're going back here, we're going back to the filter, and we're removing the filter. It's done and dusted, it's gone. But you have used now a filter to copy your data in another spreadsheet. So now you have your results from the candy example in another spreadsheet. Good, filter, super, super important. So duplicates. You know the problem with duplicates, right? You sometimes have duplicate entries. You want to remove them. You can do easily by basically selecting your data, go and remove duplicates. My list has headers, okay. Which duplicate do you want to kill it for? You want to kill it for column A. And here the duplicate is done. It tells you one duplicate was found and removed, 10 unique values. This is how you remove duplicates. What else is important on quick? The text to columns. Now this is specific, group and ungroup. Pivot tables. Nah, this is okay, if you want any other function, you can also go in any cell and you click here the FX symbol. When you go on FX, it gives you here the formula builder. You can count, you can do t-test, you can count if, which is something we're going to do down the road. Count if is, for example, if you want count range of this and this and this. Oops. Count if, count criteria range. Range. This criteria 1, criteria range. So now we have criteria 1. Criteria 1 is, it is gotta be 1. So if you go on done now, it will only count those that are 1. This in principle is the same as doing this, but let's imagine this would be coded like an SPSS with 1s and 2s. The female is now 1 and 2, 1 and 2. And we're saying, okay, so if this is, if E2 equals 1, then give me a 2, otherwise give me a 1. So now I will recode the whole thing into 1 and 2s. And now we're saying, okay, so if, so now obviously if we would do the sum, this is not other rubbish, right? It doesn't help you. So now count if is the way out. So count if can essentially be employed that you are counting now only the 2s. So no, not E. Okay, count if is now that's count if with 1s, count if with 2s. Oops. Count if with 2s. And this is basically count if the range count if is basically this comma, rounded counting the twos, not only counts the twos. Now, if we are doing this now, count if with female, it's getting a little more complicated. Now we do count if range of this, comma, female. And this will count all the female entries, again 5. Okay, so this is count if. What else is important? Just as a quick show, you can draw, you can do margins, you can do formulae. You can search through all the formulae here. You will find a million different formulae for whatever you're looking for. Today is daily, gives you the time of the day. So if you have a template for a report, enter the today function, it will give you the day-to-day, week num, work day. It will give you the exact day for whatever date you're throwing at it. So if you want to know your birthday, and you say you were born on the 3rd of January of 1923, and you want to know weekday of this, will basically give you 4. That's a little complicated because now return time is Sunday is 1 through Saturday is 7. Use 1 for Monday through Sunday. Use 2 for Monday 0 to Sunday. Okay, so we need to specialize. So the default is, if I remember correctly, oh, this Thursday. Okay, so we're doing use return type is gonna be Sunday equals 1. Now we want Monday equals 1. So we use 1, use 2. So now we're using 2, and now we know. Oh, this point is going to be comma. Okay, so now we have okay, let's do Monday. Monday is through 7, Sunday. So Monday is now 1. So our return type is 3. So we have Monday equals 1, Tuesday equals 2, Wednesday equals 3. So that was a Wednesday. So this is now, yeah, I'm not going to go too deep because with VLOOKUP, you can create a function that basically looks that up. But we know now, since we used return type 2, you can look that up here. 2 is Monday equals 1, Sunday equals 7. So Monday, Tuesday, Wednesday makes the 3rd of January of 1923 makes it a Wednesday. Good. This is this. What else? What else could be relevant for you guys? Okay, so these are the formulae. Just go through, play around with the formulae. Nothing can happen. More different analysis. Last thing, which I want to show you. And this is a neat little thing. This is called a web plot digitizer. If you're ever in that situation that you want to have a paper digitalized, let's go on any random paper. Okay, let's go through my papers app. So papers is the software that I use for. Get to it, go to my library. Okay, so we're taking now any random paper. And we are going to any random graph. Where's the graph? And we want to digitalize this graph, let's say. That was not a good example, no graph. Let's take this. I'm taking specifically papers that are now graphs again. Oh no. Again. That's perfect. Oh, actually, you know what? Let's actually take this. Okay, so we are taking now this graph, safest picture. Okay, we're going on our Webplot digitizer. We're going here. So now we're going Webplot digitizer. This is Webplot digitizer, means like it's a plot. You can, there's a desktop version, and you can essentially here into this field, you can load whatever you want to load. So this is a 2D XY plot. You can do bar plots, you can do polar diagrams, you can do whatever you feel like doing. You basically are being asked first to align the XY axis. So first you tell it, where is my X starting, where's my X ending, where's my Y starting, and where's my Y ending. Proceed. So you go on this, and you go all the way to the right, and you grabbing here the end of your X. So there's X1, X2. This now we're going back to this, to the point of origin to get the Y1. We're going to 14, which is our Y2. Now we're done. So X-axis start is 0 and is 16. X-axis start is 0 and is 14. Good. That's our graph. So now what we have now is essentially we're going to each of these data points, and we're selecting now each of these data points. And by doing so, we're getting something that's pretty cool and quite helpful sometimes, because sometimes you want to play around with data and you just want to download data. So if you go on view data, you get here data, which copy the clipboard. You just go on this one. Digitized. Now you can just copy it in. You get it now in here. You can also export it as a CSV file. Now we're back to text to columns. Okay, so now we have here the first entry. So we have 10 rows. We have the first entry, the second entry, separated by comma. And now we can use this data by going on data. And this is also quite important. So text to columns, if you have text like that, so this is text, right? It contains a comma and like some numbers, yeah, but it recognizes a text. For Excel, this is at this point in time, not a numeric value. So it will basically treat it as text. And to make it a numerical value again, you need to go on text to columns. Super useful function sometimes. And text to columns, so there's a wizard which allows you to make your life a little easier. So basically you have either delimited or fixed width. Fixed width is good if you know exactly how far it goes over. If you know it's exactly X, Y, Z, or like, I don't know, 10 decimals or 10 entries, then it's fixed width is fine. Generally, I would recommend to do delimited. Delimited is one of these commonly found exports. So then you basically can tell it what delimits my numerical values. As we know, here for us, it's commas. We don't need tabs, we say comma. So you see already, if I do semicolon, for example, it keeps it in characters. This will not help us at all. If I do comma, it automatically gets in the second column. Now we just need to go next. Now we can kind of pre-select the format. You're not interested in that. You can finish. Ta-da! You have your two separate columns. So now what we can do round. We can do round of this by 0 digitals, because we know it was only full values. We do this, and we again pull this over down. Now we get our data. Now we can compare it to our original data, and we will see it's consistent with our original data. So it's obviously not really, but it is to the extent that we see. And now we'll delete this. So now we can sort this, or sort by the magnitude of sort by column G. We get now smallest to largest. That was terrible. Okay, we go back to sort. Sorted my list as headers. We sorted by column. Okay. That was not really. Okay, first attempt is on the x-axis. Okay, so first we need to sort. We need to sort first the original data, right? So we sort this on first attempt. And now we sort this whole thing by first attempt as well. By that, we get the numerical value essentially in the same, sorted in the same fashion. And we see already that we did well in digitizing our data, and now we have the data digitized from our from that software. So that's very useful, because sometimes you have graphs from data. You want the data, you want to do some simulations on it, you want to do some analysis on the data. You can do this with every data on that you find anywhere on the web. So you're interested in data, you're interested in understanding this data. You go and you copy that plot into the software. You can digitize all your data and you can do your own simulations. And this can be hypothesis generating, and this can lead to you contacting the authors, starting a scientific excursion, discussion about the data. This can mean a lot of things. Also for example, what we did it for mathematical modeling. So it's like I work with mathematicians on mathematical models, and I helped them to get data, provided them with data that they actually needed to estimate parameters based on their that was necessary for their models. So this can be really super useful as a tool. Good. All right. So since there were no specific requests, I did show you now pretty much all that I think is quite useful. Since there were no specific requests, I would be concluding here. If you have any further questions, let me know. I'd be happy to get on a one-on-one or do some specific explanations. All right. So see you on Wednesday. Bye-bye.